Hello students, today we're going to be working with Chapter 9, Section 7. This section is called Systems of Equations. A system of equations is when you have more than one equation. So it's called a system. This chart is found in your book on page 505. Please copy this whole chart and then I'll talk about it a little bit into your foldable. Okay, the chart shows three different situations of how you can have two lines or two equations on the same graph or on the same grid, or looking at two types of equations. So in the first situation, we've got one solution. So in this case, we've got two lines that are graphed, and when you graph those two lines, you can see that they intersect. It means they cross, and they cross right there in the middle. That intersection point is the solution. So there's one solution, and that solution would be an ordered pair xy that both of those equations have in common. They share that common point. That intersection point is the solution of those of that system of equations. So that's one of the cases when you have two lines. The slopes are different for those two lines, and where they cross is called the solution. So they have the same x and the same y that work into both those equations. So your solution is that ordered pair where they cross. The second type here, we've got parallel lines. So we have two lines that are parallel. That means they'll never cross. So if they never cross, they never intersect. Since they never intersect, there's no solutions. So in this one, we've got no solution or empty set. They never cross. In this case, when you look at the equations, these two lines would have the same slope. They would have the same rise and run consistently throughout the whole graph, but their y-intercepts would be different values because they would be crossing the y-axis at two different points. So the b values are different, but the m's, the slopes, are the same. So if you have two equations that have the same slope but different b values, that means there would be no solution. These lines would never cross. There's no xy ordered pair that would be the same in both equations. And the third type we have is called infinitely many solutions. That's when we've got a situation where the y equals mx plus b is exactly the same for both equations. These are the same line. So we say that they have infinitely many solutions, or sometimes we just say they have infinite solutions. In this case, we've got the slopes are the same and the y-intercept is the same. So in the last lesson, we talked about different forms of the equation. So this would be a case where you've got maybe a couple different forms of the same equation. Once you graph them, you'll see that the two lines actually are overlapping. So it's like one line right on top of the other line. So when you graph them, they actually are exactly the same y-intercept and exactly the same rise and run, all the way through that whole graph. So they're exactly the same line. So we've got one solution, no solutions, or an infinite amount of solutions. Sometimes when we talk about this infinite solutions, this is also called an identity graph. So some books you might see it as an identity. Some of them might be written with just infinitely many solutions. So identity means that all solutions. So sometimes we would write this, we use that all reals before. All solutions or all reals. All of these ordered pairs, since all of them are crossing, all of them are intersecting. This graph is intersecting everywhere. This would have all solutions. So all XY ordered pairs from one graph would be the same for the other graph. So you've got all solutions. This is called an identity, infinitely many solutions. We've got 3 examples that we're going to look at, and we're going to solve each of them by graphing. So you're going to definitely want some graph paper for these 3 examples. In the first set of examples, we're looking at 2 equations here, y equals x minus 1 and y equals 2x minus 2. We're going to look at graphing these, and then when we graph them, we're going to look at what does the picture look like. Is there infinitely many solutions? Is there no solution? Or is there one solution? So this is already in y equals mx plus b form. So when there's no coefficient, we put a 1 there. So here's our m. And in this second one, we have m equals 2, or 2 over 1. This is 1 over 1. Our b value, remember that's our ordered pair, is 0. In this case, it's 0, negative 1. Over here in this one, it looks like 0, negative 2. So when we graph these 2 equations, the first one I'm going to graph, oops, put that in blue. And I'm going to start with that 0, negative 1. Okay, and then I'm going to do what the slope says. So the slope is your rise and run. So I'm going to rise 1, run 1. It's my next dot. Rise, run. Rise, run, and we keep going. So what I'm going to do is I'm going to take this blue line over here. Maybe. I'm a little crazy here. And I'm going to put that line right where we have those blue dots. Okay, so that blue line is just using a straight edge, drawing that graph based off of those ordered pairs. Okay, and in the next graph, I'm going to do the same thing with the green. So I'm going to start with this negative 2 for the ordered pair because that's where my y-intercept is, negative 2. And on this one, the slope is rise 2, run 1. So if I rise 2, run 1, you can see they overlap already. Rise 2, run 1, rise 2, run 1, rise 2. Okay, so we just keep going with this. So what I'm going to do is I'm going to take that straight edge, take my line over here. Why are my dots going all crazy? There we go. And take that line. Okay, so we had a little technical difficulty there. So we got the graph on there. Now we used a straight edge, and I showed where the 2 graphs, the blue line and the green line, where they look on the graph. And then you can see right down here, this is the ordered pair where those 2 lines cross. So where those 2 lines cross, that ordered pair is 1, 0. So it just happens to be on the x-axis. This is just a coincidence. So what this means is that is the solution for this system. So when x equals 1 and y equals 0, that's an ordered pair that works and makes a true statement in the first one and in the second situation. So that's the only ordered pair that these 2 equations share. So that's how you would write your solution then, either in ordered pair format, or you would list out x equals 1, y equals 0. Here we go with example number 2. So we're looking at, again, a y equals mx plus b format. So we've got our M and our B value, our M and our B value. So if we graph this first one, we're going to graph that ordered pair 0, -1. So I'm going to go over here to 0, -1 and put a dot. And then the slope is -4/1. So I'm going to go down 4, 1, 2, 3, 4, and over 1. So now if I put that dot, and if I want another ordered pair, I can go up 4, 1, 2, 3, 4, and to the left one. So notice it has a negative slope, so it's going down to the right. So now I'm going to connect these. Oh my goodness, it's not working so well. So now we're going to go ahead and graph that second graph, and when we graph this one, I'm just going to use the 0, 6 as the B value, and then the slope here is -1 over, or -4/0. So 0, 6 is way up here. And then again, the slope in this one is -4, 1. So I go down 2, 3, 4, and I run 1. There's an ordered pair. 1, 2, 3, 4, and I run 1. So since you, so I just connected the dots with the straight edge, and then since both of these graphs have the same slope, you can see by the looks of the graph that these two lines are never going to intersect. So since you have a situation where they're never intersecting, these are parallel lines. So if you have parallel lines, that means that you have no solution. So these graphs never, since M equals M, they have the same slope. So these two graphs never intersect, so there's no solution. Okay? And moving on with our example number 3, again, we're going to look at graphing these two lines, and then once we have the graph, then we can look at where do those two lines cross. Notice these two lines are almost in like a point slope format. Not quite, but they're not in slope intercept form. So that means we need to get them into slope intercept form. So I'm going to draw that line. I want to get the y all by itself. So this first equation, y equals 2x minus 1. So that means our b value is at 0, -1, and our slope is 2/1. So I'm going to put those dots on the grid, 0, -1, and the slope is 2/1. So I'm going to rise 2 and run 1. This is a positive slope, so it's going up to the right. Okay, and then I'm going to connect the dots with that straight line. And now that we connected those, we're going to put the second equation, this y plus 3 equals 2x plus 2. We're going to put that one on the graph. But in order to put that one on the graph, we have to get rid of this plus 3. So that means we need to get y all by itself. 2x is all by itself. There's no other x terms. And here we have a -3 that we add to both sides. 2 plus -3 is -1. So here again we have the ordered pair 0, -1. So when we put these dots on the grid, we're going to start at that 0, -1, and then look again, we have our slope, which is the same, up 2, run 1, rise 2, run 1. So we end up having two lines that are overlapping. So I tried to put that orange line right on top of that purple line so you can kind of see it. All of those dots are in exactly the same place. So when you have a graph where the two lines, the two slope intercepts, the slopes are the same, the b values are the same, they have the same 0, -1 y-intercept, and they have the same slope. These graphs are the same line, and if they're the same line, we have two names for this. One of them is called identity, and the other one is called infinite solutions. So either one of those would be fine. Identity or infinite solutions means that all of these ordered pairs on this graph, anywhere that's an ordered pair, an XY on the purple graph is also an XY ordered pair on that orange graph. Thank you for watching. If you have any questions, please let your teacher know.